Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine a world where AI doesn't just think, but changes how it thinks mid problem. That's the core idea behind the chain of mindset. Reasoning with Adaptive Cognitive Modes by Tianyi Jiang and Arctanx. This isn't about making models bigger, it's about making them cognitively flexible. And in the next few minutes, I'll walk you through how they built a system that reasons more like a human expert, switching strategies step by step. Here's the problem. Most LLM reasoning methods, like chain of thought or tree of thoughts, lock into one strategy. They either reason step by step or branch or call code. But humans don't solve problems that way. Think about a geometry proof. First, you visualize it. Then you analyze logically. Maybe you explore alternative constructions. Finally, you compute something precisely. That's multiple mindsets inside one solution. But existing systems either pick one mindset for the whole task or select a strategy at the start and never adapt. That rigidity limits intelligence. So, what do they propose? A framework called comes up chain of mindset. It decomposes reasoning into four cognitive modes: spatial, visual grounding and diagram generation; convergent, deep logical deduction; divergent, multi branch exploration; algorithmic, precise code based computation. And here's the key twist: a meta agent decides step by step which mindset to invoke next. It follows a loop: plan, column mindset, internalize insight, replan if needed. Each mindset runs in isolation. And between them sits something clever: the context gate. This gate filters what information flows in and out. It prevents context pollution and reasoning bloat. So instead of dumping the entire history into every step, it passes only what's relevant. Let's look at a case study. They use a Fermi problem. If the sun were the head of a body, how long would its arms be? First, spatial mode generates a proportion diagram. Then, convergent clarifies whether head size means radius or diameter. Finally, algorithmic computes the result. That's dynamic switching inside one reasoning trace, and importantly, it can replan midway if a strategy fails. Now, the experiments. They evaluate across six benchmarks: AIM 2025 Math, Real Fermi, Live Code Bench, GPQA, Science QA, MathVision, Maze Spatial Reasoning. Across both open source Qwen3-VL and closed source Gemini 2.0 Flash.com achieves the best overall accuracy: 63.28% on Qwen3-VL, 52.41% on Gemini. It outperforms the strongest baseline by nearly 5%. And here's the surprising part: it sits on the Pareto frontier of accuracy versus token cost. High performance, moderate computation. The ablation study revealed something critical. Remove the context gate, accuracy drops sharply, and token usage explodes by 87%. That means cognitive switching without filtering causes chaos. Each mindset also shows task specific value. Remove divergent, math accuracy collapses. Remove spatial, multimodal performance drops. Nearly 60% of problems invoke two or more mindsets. This validates the multi mindset hypothesis. What's powerful here? It's training free, no fine tuning, no new weights, just structured orchestration. It also generalizes across models, open source and closed source. That suggests metacognitive control might be more important than scaling. Chain of mindset shows us something profound. Intelligence isn't just about thinking harder, it's about knowing how to think next. And maybe that's the next frontier of reasoning systems. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.